Hello everyone, welcome back to Coding Charms. In today's video, we are going to be solving the problem find all anagrams in a string. In this problem, we are given with two strings S and P. We have to return an array of start indices P's anagrams in S. You may return the answer in any order. An anagram is a word or a phrase formed by rearranging the letters of different words or phrases, typically using all original characters exactly once. So what is an anagram? If we have ABC, we can rearrange the characters in ABC to form the new string. So it can be CBA or DAC and so on. So we have to use the same characters and we can rearrange them to form new strings. Those are nothing but anagrams. We can also call them as permutations. So let us take a look at the examples. In this case, we are given with the string and the pattern P as ABC. We have to find if P exists in S. If they exist, we have to return all such starting indices of this anagrams. So if we observe here, we have CBA, which is an anagram of ABC. So we return the starting position, we add the starting position 0, and then if we observe, we have CAB. BAC is present over here, so that's also the anagram of ABC. So we added starting position to our result array, and finally we don't have any other anagram, so we return the two indices. And then in the second example, we have AB and the pattern string or the second string as AB. We have to find if AB's permutation exists in S. If they exist, we have to return all the indices of them. So here we have AB, which is a permutation of P. So we return 0, we add 0 to our list, and then we have BA. BA is also a permutation or anagram of AB. So we add 1 as well, and then we have AB again, so which is the same as the pattern. So we add 2 to our result as well. We are at end of the list, so we return 0, 1, 2 as our result. So how we can solve this problem? This is very similar to the problem permutation in a string, where we find how if S2 contains a permutation of S1. So we are basically checking if the string 2 contains in S2. So how we can use this problem to solve this problem? So I would recommend you to first watch this problem solution video. I have posted it. You can find that in the I button. So we can use the same code, the same approach. So here we are using the sliding window approach. So let me copy the same code. And there we were just checking if the P exists in S or not. If exists, we directly return true. But here we have to find all the indices. So we use a vector to keep track of all the starting indices. So whenever we found a permutation or an anagram, then what we do? We push it to our result array. So what will be the starting position? So I minus m plus 1. I is the ending position. So the starting position will be I minus m plus 1. So we add it to our result array. Finally, we return the result array. Let us run the code. We got a compiler error. So in this, let's change this as S1 and this as S2. What do we have here? So we have S1 as the, okay. So P should be S1, okay. This should be S1 and this should be S2. Now this works. It passed all the sample test cases. Let us submit it. It passed all the test cases. So the time complexity of this approach will be O of n plus m, because we are iterating over n once and we are iterating over n once. So it will be O of n plus m. And the space complexity will be O of 1, because the maps can have at most English characters. So the English characters are 26. So O of 26 is nothing but O of 1. So I hope you have understood today's problem. It is basically the extension of the problem permutation in a string. So I hope you have understood both the problems. If you did, make sure you hit that like button and subscribe to Coding Charms for more daily videos.